Welcome to my 3D printing presentation. Actually, when I thought of that subtitle there, I thought, oh, yeah, ins and outs, that, you know, all about it, you know. But then I thought, it's got a double meaning, hasn't it? Like with 3D printing, you've got the ins and you've got the outs, which I'm going to talk about tonight as well. So let's go through. The need to print. I'm retired now, and one of the things I'm actually doing in my spare time is working with electric vehicles, and I've got a conversion Holden Barina, which I converted back in 2008. I'm just recently putting a new motor and controller in it, and I've just recently put new batteries in it. And when you're installing these sort of things, you come up to problems where you need to have something that you can't necessarily buy. If you look at that particular picture there, you'll see a little terminal between the V and the W that hasn't got a cover. Now, the voltage on that pin is high. It's like 144 volts, so you don't want anyone to touch it, and it's in full view when you've got the bonnet open. So, but you normally have the power turned off, so it shouldn't be a problem. So what I thought, what I did, I measured the connection and the black bit where it bounced through. I did a little pencil sketch of that. Did a technical drawing, which I'll show you later on how I did that, and came up with that, a little cover, and that actually just clips over the terminal like that. So it covers it up, keeps it safe. So that's my need to print, and there's been other things which I've done. I've got the example of those here. Actually, there's two. One of them was a preliminary one where I didn't have that that little bit sticking out, which enabled it to clip on. It was just straight before. That one's just the first one I made, and that one's with the additional little pieces there coming out. That's the beauty of 3D printing. If you make one up and it's not exactly right, you go back to the drawing and modify the drawing and print another one. So they would have only taken like half an hour to 3/4 an hour to print. Whereas something like that probably took nearly 3 days to print. So it's done on my printer, on my new printer. So there it is there, all nice and safe. Types of 3D printing. I'm not going to spend too much time on this because it is fairly, there's a lot of reading, and I'm not going to allow you to read every slide anyway. So, and after this presentation is finished, I'm going to put on the website, I'll put the PDF of this presentation on the website, and you can go through in more detail and look at it then. The first type is fused deposition modelling, and that's this type of printer here, and also the one that I'm using now. It explains it there. A filament of solid material, plastic material, is fed through a heated nozzle. I'll go into a little bit more detail on that later on. That's the first type. The second type is it uses a resin. So instead of using a plastic filament, it uses a liquid resin, and it gets set by feeding light into the resin, and the resin sets. And it's still done in layers, but it's done with a resin. And that's another one that uses resin as well. That one there is using powder. Some of the bigger printers, very much more expensive printers that they used in universities and big companies around the world, they use a powder which can be a metal, any metal. It can be aluminium, can be titanium, it can be steel, it can be aluminium. It's just a very fine powder, and that's also done in layers. And that one there is a thermal energy source. That one there uses droplets of material. That one there uses a laser. Some of them use electron beams. But all these are using powder. The machines are very, very expensive, and also they can be very, very large, and they can make very big objects. Some of the objects they make with the powder printers, so using like titanium and stuff like that, it's actually stronger made with one of these printers. The object is stronger than if it's made by using a casting method or machining method. So that's one good thing. And what's this one? This is another one which heats the powder to a point where it fuses on a molecular level. Then this is using powder using the electron beam. So there's just so many. Tonight we're going to concentrate on the fused deposition modelling, FDM, sometimes known as fused filament fabrication. One good thing is you don't have to worry about these terminologies. When you go to JCar and buy a 3D printer, this is the type you'll get, you know. Now this is just expanding that other little bit about the extrusion of the thermoplastic material, possibly PLA or ABS. I'm using all these things, objects here are done with PLA. It's actually a plastic filament derived from corn. So, and it's got a lower melting point than ABS. ABS is good, but you need very good ventilation with ABS because the fumes given off as it's printing are deadly. So, you know, you do it outside or do it with a big vent, or leave the room while it's doing it. Yeah, the printer deposits the material on the build platform along a predetermined path where the filament cools and solidifies to form a solid object. The 3D printer. Now, this is the printer I'm using at home. It's very big and high. It's about this high. So it's sort of too big to bring along. And if I brought it along, I'd mess up all my levelling and so forth that I bring it along. So when I had to upgrade from this one's got a build plate of 220 by 220, and it'll do about 250 millimeters high, whereas this one does 300 by 300 by 400 millimeters high. So it's quite a big. You can make a very big object with it. It would take a long time to print, but yeah. So that's where it comes from. It's not purchased. You don't purchase directly from Creality. You can, I think, but there is an Australian agent called called 3DPO, which is 3dprintersonline.com.au. Now this is an example of the filament. I was going to bring some filament tonight for you to handle, take away, whatever, but that's what it is. It's 1.7 millimeters in diameter on a 1 kilogram reel. And in this case, I used to have a stand next to it, and the filament used to go up through here, through that little hole. I 3D printed that, and then down into the 3D printer there. Whereas this printer is a little bit different, which I'll show you soon. Oh yeah, the software that I use to design any of these things. That one I didn't design, I'll go into that later. All of these objects down here I did design. Okay, I had to do a 3D drawing of the actual object, which is then fed into the printing software. So the printing software creates what they call an STL file, stereo lithography. Is that how you say it? Yeah, that'll do. There are some free 3D design packages. Tinkercad, SketchUp. Actually, SketchUp is not free anymore, evidently. Tinkercad, it's an online one. I didn't like it much. It's a little bit funny to use, but a lot of people love it. I did start off with a cheaper one called Cubify Invent, Unfortunately, that's no longer available, and the one that I'm using now is actually derived from that product. Another company's taken it over, and they're actually developing it further and making it a lot better, actually. And the one that I'm using now is allows you to do assemblies, so more than one object. You can actually assemble them in the editor. Yeah, so you need an STL file from somewhere. Either design it yourself or download it. Thingiverse is a very, very, very big website. This dinosaur came from Thingiverse, so someone else had got the STL file, designed it up, and they just put it on Thingiverse website, and you can just download it. And so this was done with, I think, four files. So you got the top, you got the bottom. They clip together nicely. That's a separate file, and the base was a separate file as well. So that's how that works. I'll put that together after. So this is Thingiverse here. That's just one page, one screen. I think there's actually, I tried to find out how many things there was on Thingiverse, but I think there could be 1 million or so people have uploaded to the site for you to download. And you can do a search for whatever you want to make. If you want to make a 6mm screw or a bolt, you just put in 6mm bolt and boom, you'll come up with possibly 20 different suggestions on ways to do it.
Eric, are they all free download?
Most of them are. I don't think there's many you have to pay for. Most of them are free, yeah. Now, the 3D design software, Alibre Atom3D. This is the one I had to purchase. So that's what happens when you load the software, and I'll show you that in a sec. It comes up to the screen. You can then open something that you've already made before, so you can reopen it to edit it, which is good, and then save it, hopefully as a different name. Or you can create a new one, or the third one is actually creating an assembly. And down below you get all of the things or some of the things you've made previously. Okay, so the last 10 or 12, 12 things that you've made previously. Little funnel there I made for a hairdresser who sells shampoos and conditioners, and she puts the bulk into little containers, so she wanted a little funnel, so I made her a little funnel to do that. That's inside the software, and you'll see that soon. I'm going to run it from here, and I'll show you. I'll design a very, very simple object in front of your eyes, just to show you how easy it is to use. That one there, to design that, it probably took about half an hour, something like that, just to work that one out. Because I have got two different shapes. I've got a circle and I've got a sort of a rectangle. Yeah, the 3D design software can export the finished project in many types. Depending on where you're going to get this made, if you're going to get it made in a place where they make it out of metal with a machine, like a what do you call those? CNC machine, right? They might need a different type of file. But this one, these type always use STL. Well, I think a lot of these printers can take other types of files as well, but the most common one is STL. So the 3D printing software, now this is, once you've created the STL file by using an export in that program that I was just showing you, you then send it to the 3D printing software. The one I'm using is Ultimaker Cura. This one is actually a free software. It's put out by Ultimaker. They're a company that actually make 3D printers, so they're trying to sell their 3D printers as well. And this program includes a slicer, which actually, from your 3D drawing STL file, it creates the G code, which is the information for every layer in the object. Okay, so each layer can be between, with my printer, it can be between 0.12 millimeters height to 0.28 millimeters. So if you've got it set to 0.12, the object is going to take a really long time to print because every layer is so fine. So if I had a layer of 0.12 millimeters, how many layers do you reckon there'd be in a 100 millimeter high object? Someone can guess? Just have an estimate? Get it very, very close. I don't think you can get any closer than that. It's actually 883. So pretty close. Okay. No, that's the number of layers in a 100 mil object height, 100 mil height, when you've got it set to 0.12 millimeters height.
How long does that take?
Oh. One of these took nearly 24 hours, the other one took about 14 hours. That was about 24 hours. And I don't think that was set on the finest either. So
the 0.12 millimeters, is that the finest?
on my printer, 0.12 is the finest. But you can get other printers which will go lower. I saw one the other day, it went to 0.1. I don't know whether any go lower than that. But
So the finer the layer of print, basically, that takes longer as well.
yeah, and the more detail that you can show. So this is what the software looks like. I'll bring that up in a minute. Now that object there is that little cover I showed you before that covers up that high voltage terminal. But that's that one there sitting on the bed. And it sort of shows you what it would look like on your printer. And that sort of pictorial view behind is exactly what my printer looks like. Because I've got it set up for the Creality CR10S Pro printer. And it thinks this one is the same at the moment, but it's not. So every printer would have its own characteristics, and those characteristics are selected when you select your printer in this program. That brings all the profile characteristics for your printer into this program, so that when it's printing your object, it comes out exactly like it should. Okay, let's have a quick look at Ultimaker Cura. If I can go back to that. Okay, so that's it. What you do here is, at the moment there's nothing on the bed. Say I wanted to print something. Let me just go into here. I should be able to bring up the... Yep, so it goes to my Dropbox, and actually, I'll bring this one up. This is something that's this one here. This one is actually making it for a friend. This actual one here was an error. That was the first drawing I made, and I made an error in that one. If someone can pick up the error after, that's good. So let's just open that. But all I had to do was go back to the drawing and make a change to the drawing, and then resave it over the top. Okay, so there it is there. Now I think I can sort of bring that up a bit bigger before it gets lost. So yeah, that one there is like very, very thin. So it's only like 1.5 millimeters thick, and that's going to print like that. And so in this case, I need to add a brim to it. So what happens is it puts a brim about 1 centimetre all the way around, right up to the actual surface of that. And you can do that in here. I'll show you. So at the moment I've got standard quality selected, so I can go in here and change the quality back to, say, super quality, which is 0.12, and then save the changes. And then down here there's a lot of things you can select. A lot of them I just leave. If you're making a big object like this, which is going to use a lot of plastic, And it doesn't have to be super, super strong. What you can do, instead of making it solid, you can put inside of it what they call an infill. And so you can actually put a different shape in, you can make a different shape. So infill is selected here, and I've got it at the moment, I've got 100%, which is solid. Okay, for all these little objects, you always have them solid. If I wanted to choose something different, hang on, I'll backspace over that. You can say 20%. 20% infill. In this case, it might have trouble because it's so thin. Okay, it might not even do infill, even if I tell it to. And you can choose the type of pattern. So you can do lines, you can do a grid, you can do triangles, you can do. There's just so many there. Zigzag, cross. The most common one is cubic, which just gives you like a cross. Or you can do the hexagon, trihexagon, or triangles. Or simply lines. So it's just basically, other than the surface layer, which you can actually set the thickness of, inside can be shaped like that. And I don't know whether in the light, sometimes you can see the infill with in the light if it's got a very thin surface layer. But what I'll do, I'll put that back to 100%. Okay, and I've got it set to lines. So it just fills it up with lines. The cooling, you can set up your cooling. You can have it so that there's a cooling fan on it. This one's got a little cooling fan here. You can have normally on fine objects, you turn the cooling fan off for the first couple of layers to make sure it sticks to the plate well, and then you can have the cooling fan coming on after that. Also, if you're making something very complex like that, where you've got internal surfaces which are horizontal or close to it, you can think the printer's going to have trouble putting something across open space. So what you do, you can put in what they call support, and that feeds support right up inside everywhere where it needs to have it. Okay, so it decides where it needs it and puts the support in. So then after you've finished making it, you've then got to push out all the support. Okay, get pliers and screwdrivers and all sorts of stuff in there to try and get the support out. And I did have a little bit of trouble with that. I thought I was going to have trouble, but I ended up getting it all out with pliers and stuff like that. They do make it very, very thin layers, and they make it so that it doesn't actually stick all that well to the layer it's sitting on. Very, very clever. You can have a close look at this one after, and I haven't done any touching up inside where the support was. So the support material is distinguishable from the rest of it. It's the same filament. Well, but it looks a bit different, or it's. Yeah, it's just done in a very, very fine. Very, very fine manner, very thin, fine, and they attach it very, very lightly to the object, which is absolutely amazing the way they do it. And this particular program does it very well. I was using a different program with this printer, and it didn't do it quite as well. Now, this is where the build plate adhesion. That's what we were talking about before, by how do you stick the object to the plate as you're making it, particularly when something's really, really thin like that. So I've got this set up to brim, and most of the things I make, I leave it on brim. I was having some trouble before with one of the printing some things even without the brim. Even if they did have a big surface area, I still had a problem with corners sort of lifting a little bit. And so I leave the brim on most of the time. The only problem with leaving a brim on is that when it's finished, you have to actually sometimes use like a needle file just to get rid of that where the brim was joined onto the article. That's the only problem with a brim. If you have a lot of trouble with the thing sticking to the plate, even with a brim, you can actually put on what they call a raft, and that puts a whole bed of plastic printed onto your plate, and then it prints the object on top of the raft. The only problem with that is it leaves a rough surface underneath, so which doesn't, a lot of times it doesn't matter, but it could be a problem with some objects. So that's where you select that. You can select that there. You can do a brim or a raft. They're the main two. Skirt doesn't actually give any skirt. What skirt does is puts a line, couple of lines around your print. And the good thing for that is it actually tests that the printer's printing before it gets to start your object. So if you don't need a brim, you put the skirt on, and that makes sure the extrusion procedure is working really well. And it's also handy sometimes if you change colours. If you change from one colour to the other colour, sometimes you have a little bit of the other colour left in the print head. And so if you started your object straight away, you might end up starting with red where you actually want white, which is a little, you know. But if you have a skirt with a few rotations set on it, that'll get rid of the red before it starts printing the white.
Eric,
Yeah.
Carlos wants to ask a question.
Yeah, sure.
Are the molds made out of steel?
There's no moulds. No, it prints directly onto the build plate and builds it up as you print.
Es el material que se usa para que se diseñe ese lo que quiere hacer, lo va haciendo en la misma.
You'll see that in a minute. I've got a video of it printing that. I've got a video of it printing one of them. We'll get to that in a minute. Okay, so once you've got all that set, you've set up the quality, you've set up the whether it needs support or not, and if you don't click the support on when you're making something really complicated, it makes a mess. It just tries to do it, and it just layers the extruded plastic in midair, and it just droops. If it's a small gap, it'll sometimes it reaches across okay without too many.
Look at the top of the skull where the larger hole is.
Yeah.
There was support
Support in all those. Yep. All those areas, and some of them are really hard to get to. Okay, so after you've set all that up, you then click on slice, and that's what I was talking about before. The slicing converts the STL file into an information file which gives information about every layer. So it's actually the information on shifting that print head in the X and the Y and the Z axis. So the Z axis is only each layer. So each layer, the next layer when it comes up is one level of 0.12 millimeters in height. So it moves the head up 0.12 millimeters and does another layer. So that next layer comes from this file that the slicer produces. So I'll now slice that with a really complicated item that you can go away and make a cup of coffee while it's slicing. So there you go, it's done it. And if this printer was able to print, I could then click via USB and that would start printing immediately. So that's basically this software. Very, very, very good. It's probably one of the best ones I've seen. You can actually set it to preview, and in the preview mode, you can actually get it to run like a little video of it printing. I don't know whether I can actually do that here.
I just have a couple of questions. Is that program connected to the 3D printer? Or you have to do it
Yeah, it's connected via USB.
by USB?
Yeah, yeah. So all the 3D printers you buy all connect via USB. So it's
There
yep.
is any difference between the trace decoder in the price, or are the same? White, red, or
The bigger the printer, the more expensive it is. and you don't necessarily get, I don't think you get the cable. The cable is, for this one, is a standard printer cable, USB printer cable.
I'm just asking, why you have one model with black, orange, and red, but is there any difference in the colors when you buy it?
Oh, you can buy any colour you want, yeah.
Are all the same price?
Most of them, yeah. The only ones that come up in price are maybe some of the ones that have got additives, like you can get a filament that's got wood in it, so you can actually make wooden looks like wooden objects. You can get some more expensive nylon ones, and AB, I think nylon's a lot more expensive. But the PLA, these ones are normally, that one I showed you, 1 kilogram is normally about $30.
And how many cases do you use to print?
That little one there is about 6 grams. So, yeah, it's 5 grams. It actually tells me there. It's 5 grams, and it's going to take 1 hour and 27 minutes to print. Okay, so so that's 1 hour 27, nearly an hour and a half. If I change that quality to standard quality, and then slice it, re-slice it, so it just goes through again. So at a lower quality, just get rid of this. Yeah, 55 minutes. So instead of an hour and a half, it's just under an hour. But still 5 grams, of course, because it has to use the same amount of plastic.
So you could print one out at the lowest.
Oh yeah,
quality,
yeah.
At the lowest quality, just to see what it looks like.
Yes.
And do it again at the highest quality.
For sure, yeah. That's what I should have done with this when I had an error in it.
Eric, you've done your software.
Yep.
What's the scene with contract printers?
Oh, I actually I'd go into that. Getting someone to print it for you?
Yes.
Yep, I go into that a little bit later. So yeah, you can actually watch a video of it like that, and if you push the play button, it sort of, it's very hard to see, but there's a little yellow print head running around there. Just showing you printing one of the layers. So it's, I don't know whether I can blow that up a bit. I might be able to blow that up. Yeah, so that's all it's doing. It's just showing them printing that layer. So you can move the left-hand side one here. That's layer 36. So you can move that one up. So there's 271 layers in this one at that resolution, at that quality. So it's interesting. These ones here have got little holes in it, and even though I did have support on, I didn't need to, because the holes are small enough to just bridge the gap, okay, when it got to the top of the hole. So that's that one. Okay, let's get out of there. That's enough of that. Is there any questions about this software while I'm here?
Yeah, Eric, the machines themselves, are they sold with any basic software packages
Well,
to complement the machine?
we'll see. Normally they suggest it, which one you can use, and this is one of the ones they suggest. They do suggest other ones as well. I haven't found the other ones to be very, very good. Some printer companies might have shares in the other companies, I don't know. But I would recommend this one, and it's free, so why not? And
So all software packages are compatible with all machines?
pretty well, yeah. Okay, so that's that one, and that's what. Oh, now we got the one that I'm using in action. So just please disregard my untidy office. It's a very, very, very small room. That's actually the roll of red. Where's my mouse? That roll of red there. On the support, they give you that support to go on the top. And then what I did, I downloaded that little thing there, which actually guides it through a little hole. and it's very, very good. What happens is, if you don't have a little guide near your roll, what can happen, if it comes loose, the filament can come off of the reel, which causes a lot of problems. It tries to drag it off, you know, and once it's done one loop, it then just trying to drag it past the centre spindle and all that sort of stuff. So that sort of keeps it central. And then down here, where's my little mouse gone? Right, down here, I've got a picture of this later on. That's a little guide which has got a little roller which guides it into the. I can show you that in a sec. So that's it there actually working. That's my build plate there. So that's actually a steel plate, flexible steel plate. This one hasn't got a flexible steel plate. This one you've got to actually scrape the object off, and that can cause damage to that surface. Whereas my plate is double-sided. I've got one type of surface on one side of the plate, and turn it over, and there's a different type of surface for different materials. Once the print is finished, I can remove that plate, which is only magnetically held on, let it cool down. I put it in front of a fan, and then once it's cooled down, I just bend the plate, and the object pops off. So it's very, 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 very good. If you make it too slippery, it won't stick. So these surfaces are made specifically. The company I got that off, the surfaces, one of them is their patented surface. They've actually made that plastic surface. And each time before I print something, I actually just polish it gently with some fine steel wool, and that takes off any residue left on there. And you do that with a little bit of alcohol just to clean the surface. And since I've done that every time, I don't have any problems with things sticking. What have I got? Got something else? Oh yeah, down the bottom, right in the middle down the bottom, you can see the little display. Where is it? Where's my mouse gone? Here it is. That down here? You can see the display, and that's it there, up close. And it's a touch display, very, very nice. And you can set up your temperatures just by touching on set the temperature and put in your new temperature, and then it shows the nozzle temperature just underneath, which this time is exactly the same, which is good. It's on a thermostat type system, so it just varies plus or minus, half a degree sort of.
The nozzle temperature have to be, if you set it too hot for the material that you're using.
If you set it too hot, you'll burn the material. Yeah.
Or just melt it and it won't stay.
No, it'll still melt it, but it'll be too hot for it and burn it. If you have it too low, it won't melt it enough. 190 is perfect for PLA. Now, and the second temperature underneath, the 77, is the bed, the hot bed. This is a hot bed as well. It's got a heater underneath it, which heats up the whole bed. Okay, and so that's where you set your temperature. I've got it set to 77 because of all the material that I've got above the bed, which is like I've got a magnetic sheet of a magnetic material to hold the steel plate down, and so the heated aluminium plate has to heat through the magnet and then through the steel plate into the top surface. So that's about 7 degrees difference between the top surface, the heater element, and the top of the plate. So I set that to 77, so I get 70 degrees on the top of the plate, which I could check with a thermal thermometer. What do you call it? Yeah, one of those thermometers that you just poke at it. Next one. So that's the reel of filament. So that shows you the type of filament. So that's 1.75 millimeters diameter. Okay, and the roll starts off at 1 kilogram. So printing stuff is not very expensive, except when you have just about every colour like I've got. So someone wants something done in green, you take the green one out, and someone wants something done. If I do these orange ones, which is the safety colour for high voltage, I use the orange. Yeah, if you don't care, you use the one you got most of. This little counter there for a game that one of my grandkids lost one of the counters for. So I had to make up a counter, then I had to print a little label to stick on the top. Now this is interesting. This 3D printer has got some very good features. Firstly, one thing it hasn't got is this bit here. I made that. I downloaded the file from Thingiverse. I had to purchase a roller bearing. There, that's a mouse keeps disappearing. That one there is a little bearing that I purchased, and it just pushes in tight to that printed thing that someone else designed. So that actually guides that filament in through that into that next block. Now that first block there.
So whoever made that 3D printer didn't think about putting that.
No, they didn't. It still works, but what happened was the filament would come straight down. No, I won't get up. The filament would come straight down here, right, and then have to go in that hole. So it went in okay, but what happened was it would just scrape on the hole a little bit, and you'd get a little bit of a build up of plastic as it's going through the hole. So this actually guides it beautifully into the hole, and that just clips onto the red surface there underneath.
Constant velocity of feed.
Yeah.
That's set up. But when I set all those parameters on the layer height and all that, that printing program calculates the speed that it's got to push it through at. Yeah.
So the speed can vary depending upon the
Oh yeah.
colour down the print.
Oh yeah. And it actually starts and stops. When you're watching, you can actually I'll just go back here with my mouse. That little block there actually senses if the filament runs out and pauses the printer to allow you to put more filament in, and then you push continue and it continues. So that's a very good feature. It actually senses the filament has run out. As the last bit comes through, it senses it and then stops. Now, if I get my mouse back, this is bit here. This is where it feeds it through. It's got a serrated edge on the motor drive. There's the motor underneath here, like a stepper motor, and that's spring-loaded against two cogs, and it just pulls it through as required, as the printing program tells the printer to pull it through. So if it's doing a continuous stream, it'll be a continuous flow at a constant speed. As soon as it has to change to a new position, that will actually stop, sometimes reverse, so that you don't get any stringing effect as the printer moves the head. It'll actually reverse a little bit to pull the filament back a little bit. Very, very clever. And then once it's fed it through that, once it's thread through there, it actually goes into what they call this little tube here, which they call the Bowden. It's a Bowden tube. So you can see it coming. The filament comes along here, inside this special Teflon tube, very, very slippery, and then straight into the printhead here. Okay. From there, it goes into through a heating block. You can see it on this one. There's a heated block here. That's got an element in it, and it's got a thermostatically controlled sensor. So it senses the temperature, sends that back to the control circuitry in the printer to try and keep that temperature exactly the same all the time. And that was the 190 degrees on this particular printer. Oh yeah, thank you for all 3DP for supplying the information on all the different types of 3D printing. I actually grabbed the text from their website, so I thought I'd better thank them for that. And that's all. Now, other than showing you the little short video of the printer working, are there any other questions?
Well, we've seen previously a video of a house being 3D printed.
Yeah.
It was in Russia.
Yeah.
It's taken some time. So, have you come across any other examples of some?
The other example, they have 3D printed a car.
3D was going to ask about that.
Yeah. They're just like this, but larger.
Yeah.
exactly the same sort of thing, but a lot larger. Yeah.
So like, you know, we build walls, whatever, on the inside of the house, and then we paint them. So you could physically build the wall in the colour that you want to paint it, couldn't you?
Yeah.
Yeah, that's a practical example that they are building houses.
Yep.
Pretty neat.
Yep. Any other questions?
I've got one.
Yes, Patricia.
So can you do the printing, 3D printing, with 2 or 3 different colours?
I can't. No. You can buy printers that have got 2 or more. You can feed them in at the same time, and you can actually do, you know, you can tell in your drawing. You've got to tell what you want, what colour you want that part to be, and then that will go to the second colour every time for that. There is also other ones with ones that have got 2 or more filament feeders. You can set one of the feeds to be support material, which is dissolvable in methylated spirits or water or something else, so that when you do an object like that which requires internal support, you can use that material on the second one and tell the printer to use that one for the support. When you're finished, you just dump it in the liquid and it dissolves the support away, which is really, really good. And they're a lot more expensive. Yeah. I haven't got to that stage yet. I can't afford that, that's for sure. But yeah, it's quite possible to do all that sort of stuff. And I think even some of the ones that have more than one colour, some of them actually mix the colours. You can actually feed the 2 colours in at once and it mixes them. So that's, you know, it's interesting.